Okay, this is the first section of chapter 12. This is a very important idea in mathematics. It's going to be simplifying radicals, but not to a decimal because that rounds and loses our precision on our numbers. So to start with simplifying radicals, and you may have seen this in one of the study islands that's due by May 15th, so hopefully if you haven't done that, this will help you. Again, this gets you exact answers of a square root. You're not going to use the decimal. I'm not looking for the decimal. That's rounding. All right, so there are two ways to look at this. Again, I want you to look at the one that makes sense for you. And you're going to do this so much that you're going to be able to do a lot of these in your head. And in your head, you're probably going to be using one of these ways. So the first way is using factoring. And with that, what you would do is take the prime factors of 45, kind of doing those factor trees you did before where 45 is 9 times 5, break down the 9 to 3 times 3. Now, a square root undoes a square. Remember what squaring is. It's multiplying a number by itself. So which number do you see is being squared? The 3's. See how they're written twice? So if square root undoes the square, then any of the doubles can be pulled out. So simplified, it becomes 3 root 5. Any doubles pulled out. Another way that sometimes people look at it is they think of the perfect squares. Perfect squares are like 4, 9, 16, 25, 36. I think you know what those are. And what they might do is look here and say, I'm going to try and think of a perfect square that can go into this number. If you look at this, 9 is a perfect square that can go into 45. So I break up the 45 into the square root of 9 and the square root of 5. Well, I know the square root of 9. That's 3 root 5. So again, this is the same. You're doing the same thing. You're simplifying the radical. It's just two different ways to look at it. Okay, so again, I'm going to talk through the top two, have you do the bottom two. So for the square root of 50, you might want to look at the factors, 5, 5, and 2. I have two 5s. I'm going to bring that out, and I'm left with the square root of 2. Or some of you might recognize and say, hey, I know a perfect square that goes into 50, 25, and split 50 into 25 and 2. I know the square root of 25, that's 5, and bring down the root 2. Like I said, it's one way or the other. It gets the same answer. I just want to go over this one real fast. Square root of 72. You can see I simplified that. Here's with the factoring. Here's with the perfect square approach. In this one, I have more than one thing that's doubled. I have a double 2, and I have a double 3. Okay, so I'm going to pull out one of the 2's. I'm going to pull out the 3, and then see how I still had 1, 2 left over, so that's going to stay under the square root. When you pull multiple numbers, you're going to multiply them. So your final answer is 6 root 2. What I'd like you to do now is to try these other two yourself. Okay, oh, sorry. I did that here too. I knew 9 went into 72, so I broke it up into the square root of 9 and the square root of 8. And then I said, oh, wait, you know what? Another perfect square can go into 8. So I broke 8 into square root of 4 and square root of 2. Square root of 9 is 3. Square root of 4 is 2. Just bring down the other one, 6 root 2. So I'd like you to try these two and push play when you're ready to check your answer. All right, over here, I'll just kind of show you the answers there. Again, I did it in both methods. So 2 root 3 should have been your answer there. And 6 root 3 should have been your answer here. You're always going to double check that when you have simplified all the way, there's no more doubles in here. Like even if you only saw one thing to bring out, always double check that there's no more doubles left under the square root. So 6 root 3 was the final answer of this one. All right, I have 4 more here where I didn't show the work, but I do have the answers. So just 4 more times. Push pause and please try these. All right, as we come back, this one is 10 root 6. Some of you might see that perfect square of 100 in there. 4 root 3 for this one. 8 root 3 for this one. And 3 root 6 for this one. If you use the prime factors, you may have found 2 numbers were left under the square root, and again, you multiply those. If you have any questions about these, just let me know. I'll be happy to help you with those. All right, over here we're going to talk about a really important principle. So here I have the square root of 9 times the square root of 4. When it's written like this, it means they want you to square root each first. Okay, so I square root of 9, I square root of 4, and now I'm going to multiply. I get 6. When it's written like this, it means do the operation first, then square root. All right, well, 9 times 4 is 36. The square root of 36 is 6. So when they were separate, was it the same answer as when they were together under the square root? The answer there is yes. So you can break a square root up over multiplication. It can be written separately or all under one square root, and that's okay. You can kind of see an example of that here. Now let's see if that works with addition. Again, in this notation, it means take the square roots first, and I get 5. Add first, and are 5 and the square root of 13 the same? No. So when it's addition, you can't just rewrite it, all of it, under one square root. So be aware of that. Multiplication, okay. Addition, no. So now we're going to pull in some additional multiplication. For this one, there's a couple ways you can do it. Okay. I'm going to show you the way I would do it. The way I would do it is... Okay, not to the right. This is the way I would do it. I don't multiply these numbers together because I always think I'm going to have to factor it anyway to figure out if there's any doubles. So I just wrote 5 and 15 together. I factored the 15 to 5 and 3, said here's a double, and I pulled it out. Now, you can multiply the 5 and 15, and if you do that, you're going to get 75. Some of you might see there's a perfect square in there, and again, you get the same answer of 5 root 3. Just one more time on this one. The 7 is going to stay on the outside of the square root. These numbers inside are called radicands. So you can see I just wrote 15 times 20. I factored the 15. There's the 3 times 5. I factored the 20, 5, 2, and 2. Pulled the doubles. I had, again, a double 5 and a double 2. So the 5 came out. The 2 came out. They all multiply with the 7. And then you're left over with the square root of 3. What I'd like you to do now is try the other 2 on this side. So try these 2 and then come back. All right, here you can see what I did. You should have gotten 10 root 2. You'll see I didn't go to primes here, but I saw that there was another factor of 10 in here. Again, a lot of different ways to think about it. And in this one, you can see I multiplied the 2 and the 4 that were on the outside. The radicands, the inside, stay together. I broke up the 12. Notice here that they were all doubles. When they were all doubles, everything gets brought out. So this actually is just 48. That's the answer. All right, I'm going to skip this one. I think it's the same idea, and you probably get it. If you need to practice these, I'd be happy to check them for you. Now, when we get to addition and subtraction, remember that what we said before, addition and subtraction we've always said is very different than multiplication. So I have 4 root 6s. I take away 7 root 6s. Okay, well, what am I left with? Negative 3 root 6s. Note, just like when we did x's and x cubes and everything, the coefficient changes, but not what you're subtracting. Now I have negative 3 root 6s, and I get another root 6. And that leaves me with negative 2 root 6. Now what happens over here when they don't match? I have a root 75 and a root 48. Great. That's not anything I can talk about. They're totally different. Well, the first thing you're going to do is look to simplify them. So I simplified the square root of 75, just like how we started this lesson, and I simplified the square root of 48. Now I look at them and say, hey, look, now I'm talking about the same thing. I have 5 root 3s, and then I get 4 more root 3s, so altogether I have 9 root 3s. Okay, so what I'd like you to do is please try these bottom 2 and then come back. All right, in this one, you may need to put the 1 there. I don't know if that's helpful, but please remember, just like 5x minus x isn't 5, I had 5 root 7s. I took away a root 7. I'm left with 4 root 7s. So be careful. This one is not 5. In this one, again, they're different, so I'm going to look to simplify Oh, they're both talking about root 2's, so I'm just going to say 3 root 2's plus 5 root 2's, 8 root 2's. On this slide, I'm going to ask you to do them again yourself and then come back to check. All right, I'm just going to reveal the answers here. I think you've heard me explain quite a few of them now. So you are welcome to push pause and look over the numbers and check to see if they are what you have. Oh, there we go. Okay, so this concludes the 12-2 notes, and there will be some work for you to practice, but these are the basic ideas you definitely need to know.